Good afternoon, everyone. My name is Ant Ducker. I work for VMware in a kind of special group called the Centre of Excellence for Security and Cybersecurity. So I lead a very small team in EMEA, and our job really is to focus on innovation around security and cybersecurity usage of the VMware portfolio, in particular NSX-T, and we'll talk a little bit later about what's to come after that. Today, though, what we're going to do is run through, as it says on the slide here, the anatomy of a ransomware attack. So this is probably going to be a bit different to what you're used to when you hear about ransomware. We're not really going to talk too much about the way that the ransomware works in particular. What we're more interested in is actually how the ransomware is realized and delivered into the networks, in particular by advanced threat actors. And things that we can do to prevent that, and think of it as kind of opportunities to protect against all of these things. Having said that, though, what we will do is start with one scary screenshot, because we have to, because we're talking about ransomware. Just to kind of highlight what we really mean by ransomware, and I guess these exciting and exotic new ransomware variants that you tend to see that kind of make the news headlines. So this particular one is a ransomware variant called Jigsaw. You probably won't be surprised to hear. Nothing particularly new about Jigsaw. This variant comes from about 2015, 2016. What is interesting about it is in our experience, this is the first ransomware sample that we've encountered that is advanced, right? That contains advanced capabilities. So what I mean by that is the capabilities that were packed into the first Jigsaw variants were polymorphism, and evasive behavior. So I guess to put that into plain English, the polymorphism is something that you see very typically today, right? The delivery mechanism will be different. Even though the malware payload is the same, it might come through via an email, it might come through via a PDF. In the old days, they'd leave a USB stick on the path outside, those types of things. But the way that the malware is delivered in waves back in 2015 was different every time. In addition, it was packed with what we call evasions. So this is like one of the first classifications of evasive malware. And what that means is, as well as these polymorphic behaviors, which are ultimately designed to evade, basic antivirus detection, there would be things packed into the malware so that when it was executed, it would do a number of unusual things. And those unusual things will be to defeat advanced malware analysis, things like sandboxing, where the sandbox is looking for particular types of behavior, and Jigsaw would change its behavior based on the environment that it's in. So these represent really the kind of advanced types of malware, even not just ransomware, that we're really worried about when we want to protect our data centers, and this kind of represents what you're going to see from an advanced threat actor. The other thing, and the other reason that I wanted to show this is, as I said at the start, right, you see a lot of amazing new ransomware variants in the news. The reality is they're pretty much all based on the same 5 or 6 sets of code base, right? There's nothing really amazingly new about them. They've just been packaged in a different way, and they've just been obfuscated in a different way. So if we're focusing on the behaviors and capabilities of the thing that we're analyzing, we stand a much better chance of identifying it as ransomware or malware. So let's get into the attack, right? So there's 2 primary ways that ransomware can get in to a network. The first one is, surprisingly, straight through the front door, right? So in this scenario, the threat actors are coming straight into the front door. Probably inside the firewall or somewhere here in the DMZ, there is a public-facing service. Not probably, definitely. And what the threat actors are looking for is a previously unknown or unpublished exploit, like a CVE, that type of vulnerability. So there are teams and teams of people, either state-sponsored or otherwise, whose day job, if you like, is to go and look for these vulnerabilities and identify them, because that gives them a route in to the network. The problem, or the difficulty, I suppose, in using this approach is the area in which you're going to land in the network is probably not the best area for you if you've got your threat actor hat on, right? Because you're still going to have a lot of work to do, probably in this DMZ layer, to get to something interesting and something useful and valuable. So this is not really the preferred method in. The preferred method in is this one, right? So think about I'd say tentatively supply chain, but more about partners, contractors, support staff, remote workers, those types of things. Because their access into the network is probably via some kind of VPN, or probably maybe even a back-to-back link. And the area in which they land inside the corporate network is much more interesting, right? There's a lot more opportunity in that area of the network to discover interesting things and to proliferate their attack. But be aware, these are kind of the most common ways in. There'll be other ways we won't talk about in too much detail today. From that point on, from that initial exploit, what we're going to do is kind of step through some of the tooling that we see pretty regularly. The attack that we're going to step through is a real attack. I've obfuscated a lot of the data, so you won't recognize anything here. But this is a real attack, relatively recent, and as you'll see, some of the tooling used isn't particularly new tooling. So that first route into the network, this initial exploit where we've got our patient 0, could be just an exploit kit. So magnitude exploit kit, again, nothing new about that, probably 2013, I want to say 2014. And magnitude relies on a particular vulnerability in the BOM layer of a browser. So it's targeting JavaScript vulnerabilities to essentially break the browser, install the exploit kit, and take control of the workload. So that is one way in. Again, it's reliant on a vulnerability that probably it knows about from previous intelligence gathering. Once that is done, the second stage is to deliver the malicious thing, right? And I say file here. It could be a file, it could be an object, it could be a blob of data, but it's going to deliver something malicious to that workload. It's going to need that blob of data or whatever this object is to be viable. And what I mean by that is there needs to be a loader associated with that in order to be able to execute that blob of data if it's not just a standard file. So there's still a little bit of work here to get those things onto the initial workload. At this point, in terms of opportunities to prevent this ransomware attack, well, we've already got lots, right? So we can look at the IP addresses. If you look very closely, you'll discover that some of these are from some very unusual places in the world. And maybe the domain name as well. So we can look at things like reputation associated with the IP address and the domain name in which we're encountering. We can look at network patterns, right? So magnitude exploit kit, I can tell you this, any good security vendor should be able to identify a fingerprint of magnitude exploit kit from its network behavior. So we've got another opportunity here. And then the third opportunity is that malicious file delivery. So actually looking at the object or the file as it's being delivered to our workload, we should be able to have a look at that, and we should be able to identify its nature, its risk rating. But if we don't do that, right, then that means our patient 0 is now exploited, and our patient 0 will probably do some kind of low-level discovery and figure out some information about the environment in which it's in. This is, for me, one of the biggest changes that we've seen over the past maybe 4 or 5 years. Usually, or in the past, we immediately expect to see command and control, right? I've got a workload exploited. I'm going to send command and control back to tell the threat actor, I've got one, right? We're good to go. The reason for the change is this is a very noisy, potentially giveaway activity, this egress command and control. I've labeled it crypto war here, but ignore the label, right? This is command and control activity. This command and control activity is not only telling the threat actor, hey, I've compromised the workload, it's also sharing intelligence from the network that it's already gathered, right? And the reason that it's doing that is this is a risky part for the threat actor. They stand a good chance of being detected with this egress traffic. If they are detected, they might be able to get that information or that intelligence about the network out so they can come back and have another go another day, right? They've got the intelligence. That's the important thing. Again, another opportunity for our defense. We're looking at the IP reputation or the FQDN reputation of the encounter. And again, if it's crypto wall command and control, that we should be able to identify that from its network behavior for sure. But if we don't, right, what happens next? What happens next is the threat actor is going to move laterally within the network. So they've done an initial part of discovery. And for particularly advanced threat actors, we don't tend to see too many lateral moves, maybe 2 or 3, potentially 4 lateral moves. What they want to do is really 2 things. They want to establish footholds in the network. So if patient 0 is discovered, I've got another route into the network. But they also want to move around that network and identify valuable data. And they also want to have the ability to kind of cause mayhem when it comes to the actual detonation of the ransomware. And I'll explain what I mean by that as we go. The tooling, so we for want of a better phrase, post-exploitation tooling is normally native tooling, right? And this comes back to this noisy behavior that we talked about earlier on. Sure, I could attempt to deliver Mimikatz or Cobalt Strike or any number of post-exploitation tooling mechanisms into the network after I've compromised it, but that is noisy compared to using, for example, PSExec, right, remote command execution, which is a very useful tool if you're a Windows administrator, but unfortunately also a very useful tool if you're a threat actor as well. And these are the types of tools, as part of that discovery phase, that the threat actors are looking for. What kind of network, what kind of workloads, what are the post-exploitation tools available to me on that network, because I want to use those. Once we're into that network, typically what will happen next is a command and control framework will be set up within the network, right? So Empire Agent is the example. That's a PowerShell-based command and control framework, very easily compiled. I don't need necessarily to deliver anything into the network in order to get that up and running. And the reason for that is, obviously, I can now establish command and control inside of the network, no egress traffic whatsoever. My patient 0 now becomes my command and control node, and my patient 0 can now be used to command other workloads that I'm going to compromise in this network. It's going to use standard ports and protocols as well, right? So it's probably going to use TLS. So it's going to be very difficult to spot that command and control happening in your network. But it is another opportunity. In fact, both of these are other opportunities that we've got to identify network anomalies in the case of PSExec. And actually, depending on how you implement the Empire Agent command and control, there should be a very good network signature and network fingerprint that we can use to identify that, depending on how we're protecting our network, of course. So again, if we don't catch it at this point, what we'll find is that malicious file or that malicious blob of data now gets moved around. So we're using this command and control network inside the data center to facilitate the movement of malicious files. In this case, it's the ransomware that we're now moving around inside the network. And again, that lateral move of files being moved either between distinct security zones or within security zones is another opportunity that we've got to identify, hey, there's a bad file that's moving around our network. We don't like that. We want to stop that. But if we don't do that, as with all of the steps, right, what we'll probably find is some kind of DNS anomaly type activity, right? So DGA, if you didn't know, is domain generation algorithm. Again, there's nothing new about it. It was developed many years ago. I couldn't tell you exactly when, but it was developed as a way to defeat URL filtering and URL categorization. So what the DGA will do is spin up a load of weird and wonderful domains that the threat actor knows about, and obviously that the malware knows about. Only 1 or maybe 2 or 3 of those domains will be live and active. The rest are just complete rubbish. What it looks like from a DNS resolver perspective is a couple of hundred weird looking DNS resolution requests against your internal resolver, most of them returning NX domains because there's no IP address associated, but a few of them saying, yep, that one's live, that one's live. And what's happening here is the threat actor is preparing for the exfiltration phase, right? So they want to identify which one of these domains am I going to use for exfiltration. Well, I need to figure out which one of them's live, and that's what's going on here. This one particularly tricky to spot, actually, because if you think about it, I don't know how, what size organizations you guys work for, but typically your DNS resolver is going to be serving what? 100,000 DNS resolution requests per day, probably something like that. And what we're looking for is to try and identify 200 of those, right, potentially. So you need a very sophisticated system in order to do that, and you need network traffic analysis classification in order to do that as well. But that's another opportunity to spot, is it DGA or is it potentially anomalous DNS activity that we're seeing that is helpful for us to stop this attack. If we don't spot it there, then we'll probably see more lateral moves. So again, the post-exploitation tooling is remote task scheduling, right? So it's just remote task scheduling out of a Windows machine. What we're interested in, is it usual, right? Is it suspicious? Do we normally see remote task scheduling being initiated from this workload to this workload? And that's the crucial part in order to detect this network anomaly. And probably as part of that, we'll see some credential stealing, some authorization token stealing. This particular one here is known as Kerberoasting, where we're stealing Kerberos tokens and reusing those Kerberos tokens by injecting them into network flows to essentially use those as an authentication mechanism when I shouldn't do. Again, these are opportunities that we've got to understand something bad is happening in our network. If we don't spot them, we've enslaved another workload into our command and control agent. Again, this is all internal command and control now. And then because we've got this one enslaved, it means we can move the malware over to the next workload. And this behavior probably will happen over and over again. I said earlier on, the lateral moves are really only going to be 2 or 3 lateral moves to discover the interesting things. But once this is established, if I want to now cause mayhem on this network, then I can use a similar process to enslave further workloads with the sole purpose of just delivering the ransomware and detonating the ransomware, right? And that's, again, quite a usual tactic these days. And that's what would happen next, right? So by the time we get here, if my clicker's working, we're seeing data exfiltration, so more DNS anomalies. That's a very common method to exfiltrate data because it's difficult to spot. And at the same time, we're going to detonate the ransomware. And now, you've got the jigsaw screen showing up on all of your workloads in the organization. Why they do the two at the same time, hopefully obvious, but this is the thing that's valuable to the threat actors in most cases. It's the data that's valuable. We've heard a lot, again, in the news about things like double or triple extortion. Maybe they'll get paid, the ransom demand. These days, it's much more unlikely that they will. So the benefit for them here is, what I want to do is get security operations to focus on cleaning up all of that ransomware and bringing, re-establishing business continuity. By the time they've done that, they might figure out that we've exfiltrated loads of data. But by that point, we've already got the data, so we don't care. So all of these techniques, are interchangeable. The particular activities that I've used, as I mentioned, these are, real-world examples, but these could change, right? Depending precisely on the environment, the post-exploitation tooling might change a bit. If the defense of the network isn't up to scratch, then they may introduce other post-exploitation tooling as well, to, whatever they can get into the network. Any questions so far? Standard stuff so far. So, how do we defend against an attack like this? I hear you ask. What we're looking for is really a combination of capabilities based on the types of activities that we see in the network or in the attack, right? And that's the focus, is what do advanced threat actors use? How do they do it? And what are the things that we could use to identify those and stop them happening? So if we change the slide slightly, what we're looking at in the context of NSXT now, so this is NSXT Advanced Threat Prevention, is a combination of different capabilities. This is as well as the distributed firewall. So let's not forget, right, we've got the power of doing very, very tight micro-segmentation, which is going to give us a good deal of control and actually benefits some of the other capabilities that we've got here. But in addition to that, we have the NSX sandbox. So we can use the sandbox to identify ingress-egress files into our software-defined data center. We can establish a risk rating of those files, and we can establish a policy. We can actually have a policy defined that says, if it's malware, don't let it in, right? stop it because we don't want malware. Similarly, for lateral movement of these files, and again, we're talking about inside of security zones. So when we say lateral, we don't mean between distinct security zones. We mean between and within security zones, because we're NSX, right? We're running in the hypervisor, so we can see everything. So again, we've got the opportunity to stop those files being moved laterally inside of our data center. Distributed IDS, IPS. So I mentioned earlier on about some of the network activity, particularly the command and control activity. So we've got an IPS capability that can identify those malicious network flows and prevent those malicious network flows. And that works just the same for vulnerability. So it's threat intelligence driven, right? That's clear. But if we know about the threat, then we have a capability to identify the threat at a network level and mitigate it at a network level. And then network traffic analysis. Because we are NSX, and I'll show you this in a bit more detail in a minute, we have the ability to use all of the workloads that we manage as network traffic analysis data collection points. So we can establish, normal behavior on those workloads, and we can understand when workloads deviate from normal behavior. And that's what network traffic analysis gives us. It allows us to identify not only network anomalies, but security relevant network anomalies. And those are the things that we're really interested in. So in the context of NSX ATP, those things constitute this NDR capability. So in ATP, part of that solution is a thing called NDR, or network detection and response. And as I mentioned, we have a policy engine as well that backs that up. So unlike a lot of NDR systems, we can actually not just tell you what happened, but we can prevent it from happening, which is kind of the important thing. That NDR system is built up of exactly these building blocks that we've just spoken about, but they're tightly integrated. So we've got observability, which is IDS, IPS, right? But also a little bit of NTA, because we're using that to gather network data. We've got threat intelligence, so you can actually classify the sandbox not only as a preventative device, but a device that will give us intelligence about malicious files that we encounter in our network. We can use that as threat intelligence about the network, threat intelligence about what's happening within that particular network. And we've got network traffic analysis, which is actually going to use both of these as data points, right? Because network traffic analysis may be interested in malware that's been delivered and the behavior of the malware that's been delivered into our network. And that may indicate security relevant anomalies, right? Because it may be that we've got malware that has network capabilities, like command and control, like most ransomware has. If we found evidence of that in our network, then we kind of know what to look for up here in network traffic analysis. And there's a whole load of other, supervised and unsupervised machine learning models that are packed into network traffic analysis to really help us out. Inside of this kind of NDR capability, we've also got correlation, orchestration, and response. So we need a way of looking at all of these things holistically. What we don't want to do is tell security operations, hey, you had a malicious encounter. Hey, you had another malicious encounter. Hey, you had another malicious encounter. If those encounters are related, we want to correlate them together and say, this is what happened, or this is what's currently happening, because that speeds up their response process, right? That gives them a head start into what's happening inside of the network. And in terms of orchestration and response, as I said, we've got a policy engine that you can use for not only layer 7 firewalls, but for IPS and malware prevention as well. So those can be used proactively or reactively, or they can be orchestrated. So there's a number of things that we can do to prevent those things from happening in the first place, or react to those things if they're happening inside of our network. The other side, I'm not going to read these things out, but the idea is really simplicity. What we're trying to do is make this a simple, integrated NDR solution that a lot of people can use, that know the kind of look and feel of VMware UI and VMware NSX, and that's precisely what it does. For those of you who know a little bit about ESX and vSphere and NSX, really what we're talking about is kind of, at its most simple level, we've got a couple of ESXi hosts in this example here. Those ESXi hosts are managed by vSphere, and we're using these two components, the NSX Manager and the NSX Application Platform, that are running the whole show from an ATP perspective. So NSX Manager obviously is where our policy API endpoints are, all of that good stuff. The NSX application platform, think of that as a real-time analytics platform. So everything that we see from the hypervisor is going to be streamed inside of NSX application platform. That's more to do with network anomalies, network traffic analysis, but there's some other things that that does for us in terms of malware prevention. So by using these two functions, what we're doing is, in addition to distributed firewall, we're giving distributed IDS IPS, network traffic analysis, and anti-malware or malware analysis capabilities, but in the hypervisor. So think really every single workload that we're running inside of this NSX managed environment has all of these capabilities. Some of it is working in SaaS, so we're actually offloading some of the correlation work up here into a SaaS tenant, and actually that's where the fully emulated sandbox is running. So from a network traffic analysis perspective, we're sending network traffic analysis through the NSX application platform into the SaaS tenant. We're sending any other encounters, whether they be firewall rule encounters, denies, allows, etc., and any IDS IPS encounters, those are all going up here as well, because we're then using the correlation engine to understand, are these events related, right, somehow or not. For malware analysis, we use a static dynamic analysis concept. The idea being, if it's really easy to detect just by looking at the file hash or just by doing some very basic static analysis, let's do that, right? Because it means we can do that very quickly and we can give an answer and a response immediately. If that static analysis doesn't give us what we need, if we don't get clarity on the risk rating ultimately of that file, then we punt it up into the SaaS tenant and we run a fully emulated dynamic analysis. That will tell us, you know, in terms of behaviors and capabilities, what that object is capable of, and ultimately whether it's malicious or not. Coming down the other way, you know, under the banner of VMware Contexta, which is our threat intelligence cloud, we're sending threat intelligence updates, including IDS IPS, and this malicious IP reputations feed update that we have packed into NSX distributed firewall. And then obviously for orchestration, if you've got an external environment, which most security operations teams have, SIM or a SOAR, that type of activity, we can stream those events directly out of the ESXi layer into the SIM or SOAR. In most cases, that's JSON encoded, so it's extremely easy to kind of deal with programmatically and uses triggers, that kind of thing.
In an air-gapped environment, so where you're choosing between the static and dynamic, deciding whether to go to the application platform or to the SaaS, how would that work?
So in an air-gap environment, depends what you mean. So the definition of air-gap has kind of changed over the years, right? I'm going to assume when you say air-gap, you mean this environment cannot be connected to the internet ever, right? Ever. In that case then, ignore essentially everything that's going on in the SaaS tenant. What you get instead is distributed firewall, distributed IDS IPS. As it is currently, because we're running this up here in SaaS, we can't do the network traffic analysis, we can't do the malware analysis. Now the kind of weird part is, if you can connect it to the internet first at deployment time, right, then we can give you static analysis, right? So we can install all of the bits required for static analysis and configure it to say, don't ever even try to do dynamic analysis. That's possible. Right. So it really depends, you know, the appetite of making that initial connection or not. Part of the reason for this thing, this NSX application platform, is we expect over time some of these things to be possible here on-prem in the NSX application platform. Full disclosure, right? I'm not promising that by any means, but I have been in conversations around that approach. And we do understand that that's a kind of important approach, because otherwise we're kind of missing some key advanced security prevention mechanisms in our environment. It is worth saying though, for an air-gap environment, it's always a funny one, right? If you want advanced threat prevention from your air-gap environment, then the focus really is more on how often you update it, right? How often you take these offline bundles and you install it in here, because if it's really sensitive data and you really need advanced threat prevention, you need to be doing that every hour, right? Minimum, I would say. Otherwise, you're potentially behind the curve, and obviously that's the reason for the connected SaaS for networks that can do it. So a quick summary, essentially at a high level, what we're giving ESX via NSX ATP is the ability to do tapless NTA. Obviously, you don't need to tap it because we're running everything in the hypervisor. The sandbox capability, if you're not air-gapped, right? Okay. And distributed IDS, IPS capabilities, as well as the distributed firewall capabilities. So we're really beefing up what's available for segmentation and micro-segmentation with these advanced capabilities. If we're using SaaS, what you get then is the benefit of the correlation engine and all the other things that we talked about that are running in SaaS, which are coming from our threat analysis unit input and inputs from machine learning. We have, as you'd expect, lots of different machine learning models that are used to crunch this data. And then when you think about that particular attack that we saw, if you don't have any policies defined, then we're able to do things like this, right? So this is exactly the same attack that we've stepped through, but from the perspective of NSX ATP NDR view, right? And what you're seeing is all of the activities that we saw. So if you think about these being our internal hosts or internal workloads, I should say, this is the inside of the network, this is the outside of the network. So we're seeing all of the lateral moves, we're seeing the DNS anomalies, we're seeing the Empire command and control, but we're also seeing all of the ingress-egress activities like magnitude, the actual malware coming in itself, and the command and control, and the data exfiltration. And this is what I meant by giving security operations a head start. These blueprints actually are built dynamically based on what's happening at the network at any given point in time. So you would have, even if you had no security policy at all, you would have the opportunity to see this blueprint start being built, right? You can't watch it in real time, but it will be updated very quickly to say, hey, we had a magnitude exploit here, and now we've seen some lateral movement. You get the idea. So it's much more helpful for security operations. We also align it all the way over here with the MITRE ATT&CK framework so that we can give security operations a bit of context in terms of that external security framework, which they find useful. And in the malware analysis reports, which I don't think I'm showing that today, you see that same alignment. So when you look at behaviors and capabilities in objects that we have evaluated, you can get an idea of what that capability is actually trying to do from a MITRE ATT&CK framework perspective. So the funny thing is, and you probably kind of realize this from how I've been talking up to this point, the answer is kind of zero trust, right? So that's really the news is zero trust really helps us out against these types of attack or any advanced attack, because what we're looking to do with zero trust, and this applies to any network, by the way, not necessarily just VMware security, any security capability that's looking to use network detection and response, if you don't have zero trust, or if you don't have really tight segmentation to begin with, then what you're going to get out of that system is going to be very noisy, and you're going to pass a lot of that noise onto security operations, and they're not going to thank you for it, right? And we're going to make their job really hard. But if we've got a really tightly segmented network to begin with, actually the advanced security layers that we put on top are quite minimal and work to our advantage. So you may or may not know, in NSX we have a thing called NSX intelligence. Think of it as, I'm still going to call it VERNI, area operations for networks, possibly. I'm going to take a guess. But the interesting thing about NSX intelligence, it's similar to VERNI. But what it will do is actually learn traffic patterns, right? So there's a huge amount of machine learning that goes into NSX intelligence, so we can observe what's going on in the environment. We can understand the behavior of workloads, and we can recommend micro-segmentation rules for those workloads, and actually give you the rules and say, if you agree with our micro-segmentation recommendations, click this button, and we'll do the micro-segmentation for you. So that's critical in order to establish a really good micro-segmented environment, which essentially you were using distributed firewall for. Once we're there, Then the things that come on top are the advanced threat prevention. Now we're here, the attack surface is much, much smaller, right? So what it means is the amount of IPS rules that I need, for example, is minute in comparison, because in most cases, those network flows simply aren't possible because I have microsegmentation. It also means that anything that we get in terms of network anomalies is most likely going to be a real anomaly. It still might be a false positive, but because we're so tightly segmented at this point, if we say it's an anomaly, it's definitely an anomaly. And by the way, that includes successive hits on a block rule on the firewall, right, on the distributed firewall. So we will classify that as an anomaly because it's unusual that a workload keeps hitting a drop rule, right, things like that. So that's of huge benefit for us as well. And then step 4, we won't talk about in any detail today. We obviously have a few capabilities for multi-cloud already. You may have heard of the thing called Project North Star or NSX Plus, so that's kind of where this is going to go in the future. But we're definitely not going to talk about that today. So I'll open it now for questions, comments, abuse.
Any news or anything around the grapevine when you start using NSX intelligence for federation?
Maybe. We'll talk after. So I mean, what I can say, there's a lot of work going on, and not just NSXi, actually, a few other things around how they work in conjunction with federation. Yeah. What I would say is, depending on your environment, NSX Plus might be the thing, ultimately, but it's not going to be the only thing, right? Because back to your point, not everybody can do NSX Plus. Not everyone can say, I'm going to run everything in SaaS. So, you know, we have to look at both sides. But yeah, not anything that I'm prepared to say on camera. Okay.
Any plans to move the intelligence back to an appliance rather than containers?
Same answer. Let's talk about it afterwards. Yes, there's definitely plans. There's definitely plans. Yeah.
I think that puts many customers off the intelligence because they say, I need to deploy Kubernetes just to have that.
Well, I mean, yeah, okay. So let's talk about that. They don't necessarily need to deploy Kubernetes, right? What they can do, and again, it boils down to the environment that they're running in. NSX application platform comes with an automation appliance. Okay, the fact that it comes with an automation appliance tells you a couple of things. But what that automation appliance will do is sort out all of your Kubernetes requirements using Tanzu. And we're not going to charge you for Tanzu, by the way. That comes as part of ATP. So it will prepare all of those things for you, and it will guide you through the deployment. If you do it that way, and I'm prepared to say this on camera, right? If you do it that way, you don't need to know anything about Kubernetes, because essentially that NSX application platform is deployed in a fully supported VMware recommended approach. So if there's any problems, that GSS, right? That's a support ticket. So you don't necessarily need to do anything.
All right. I am asking from the perspective of a customer I'm working with at the moment, and there are some subsidiary of MOD, which means dark side, which means GSS are no good in this case.
Yeah. Which means you can't do it that way anyway. And the thing about that is it means you can use and consume NSX intelligence, but nothing more, because it's a dark site. And then, yeah, fair enough. In that case, it means from a Kubernetes perspective, to have an environment in which to deploy NAP in the first place, they need to be in control of that. That's not to say that we can't help, but yeah, then the support lines get a lot more blurry, right? Or a lot more solid, I should say. Yeah.
Right, thanks.
Any other questions? Perfect. Thank you very much.